All right, it's a big day. We're starting chapter 2. We get to start looking at tangent lines and how they apply to calculus. Okay, to me, this is like when it starts feeling like we're really doing calculus for the first time. Okay, so get excited about that. So, what we're looking at today is the derivative and tangent line problems. Okay, so we're looking at tangent lines and derivatives. They're used to we find tangent lines. We use it to find velocity or acceleration. We use it to find mins and maxes. And of course, we use it to find area. All right, that's a big thing. Area and volume is what a lot of calculus is used to find for weird shapes and weird problems like that. All right, so let's start looking at what tangent lines are. Okay, so a tangent line to a curve. What it is it is a linear line, if you see this picture right here, that's hitting this curve at one point. It is only touching at that one point right there. Okay, you could have pretty much infinite many tangent lines because there's infinite many points on a continuous function, right? So it could be any point on the function and the line that is tangent to that. Mostly what we're looking at is the slope of that tangent line at that one point. Okay, so the definition of a tangent line, it touches at one point. Okay, that's how I think about it. It's a line that's just touching at one point, and we're finding the slope of it. So to find the slope of a tangent line, you got to start by finding the slope of a secant line through the 2 points. Okay, so through 2 other points on that graph. All right, so what we're talking about secant, we're talking about a line that intersects. Intersects 2 points on a curve. All right. So instead of intersecting one line, we're intersecting 2 points on this curve. So in this case, if you look at this picture over here, right, we're trying to find, this would be the tangent line, right? It's only touching at one point. And a secant line might be, it looks like they're drawing it up to be the line that goes through these 2 points. Okay, so you got your points A and B, and then you want to find that tangent line. So, as you see, we got it kind of like, this is like what we did yesterday or 2 days ago with the average rate of change. All right, we started out, we're talking about our slope, our secant, right, between 2 points. I'm talking about that right there. All right, then we talked about how we can plug that in to our difference quotient, right? That's what this ends up being. Okay, so that's all we're doing. We're using 2 points, and we're eventually squeezing them down together. As you can see in number 2, to find the limit as those 2 points get closer and closer together, right? So remember, our delta x is the distance between these 2 points, right? That's the x distance between the 2 points. So we want to find the limit as x goes to 0, and that'll help us fine tune, wean it down, boom, 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 so we can find the slope at that one point that we're looking for. Okay, as you can see right here, we're taking the limit of the change of x, or change of y over the change of x, which is the same thing as our difference quotient. Okay, so we're taking the limit of this. So step 1, pick out our 2 points. Step 2, plug it into the difference quotient, take the limit as delta x goes to 0. All right. Derivative function, the derivative of a function. All right, the derivative of a function, f at x, is given by the formula f prime of x. Okay, this is said f prime of x. Okay, that's how you say that. F prime of x equals the limit of delta x going to 0 for our difference quotient. All right, this should provide, and this is if the limit exists. Okay, so different symbols for f prime, as you can see. You'll be seeing this a lot with calculus going forward. Y prime, yeah, it's the same thing as f of x. So in your book, they might draw those out a bunch of different ways. For most of this lesson, we'll just be using the f prime of x. But bookwork will definitely show you all those different ways. Or if you look up any online sources, it's dealer's choice. Anybody who's teaching, they have certain ways they learned it, and they stick with them. Okay? So understand those different symbols for derivatives. There's a lot of them, just like everything else in math. It's almost like they're trying to confuse you, right? All right, so best part of every day. Let's hop into those examples. So example 1. Example 1, we got f of x equals 2x minus 1. So to find our f prime of x, we have to find the limit as delta x goes to 0 of our difference quotient. Okay, of our x plus delta x minus f of x all over delta x, right? All right. So I'm going to zoom in a little bit so I can write smaller. So this equals, again, we got to write this limit every time. Don't forget it. All right, so if we start plugging in our equation, we're going to have 2x plus delta x minus 1 minus 2x minus 1 on top, all over delta x. Okay, we start canceling stuff out, or actually we're going to expand it before we cancel it. Expand it out, you got the 2x plus 2 delta x minus 1 minus 2x plus 1 all over delta x. Okay, so we start canceling this stuff out. That's gone. See ya. -1, +1. Just like that. Okay, we get down to this next line. We still haven't taken the limit, so we're still writing it. You're going to end up with a 2 delta x over delta x. And as you guessed it, they cancel and you get 2. All right. So again, when you take the limit of a single number, you just get that number itself. All right, not too hard. So a lot of that stuff we were doing with the difference quotient before, those proofs and everything, that's how you do these types of problems when you're doing it with limits. Okay, and I will tell you that as we go through this section, we will learn more and more shortcuts, okay? Right? Calculus doesn't look like this all the way through, but this is how we're building. So, going to number 2. Now we got a little bit bigger function. All right, nothing changes though. Still the same process. We have our f prime of x. It's going to equal the limit as delta x goes to 0 of 3x plus delta x squared minus 2x plus delta x plus 1 minus 3x squared minus 2x plus 1. Okay, make sure you have all your work written out clean and clear so you can understand it all. I'm going to change colors every line, so hopefully it's easier for you guys to see. Okay, so that's our first line. Now we're going to expand it because it can get bigger, believe me. Okay, you expand it out. You're going to have 3x squared plus 6x delta x plus 3 delta x squared minus 2x minus 2 delta x plus 1 minus 3x squared plus 2x minus 1 all over delta x. Okay, nice thing about all this is once you write it all out, you get to cross it all out. Something satisfying about canceling stuff out. All right, those 3x squares cancel out. We got a negative 2x, we got positive 2x. I believe, yep, and there's our 1s that are canceling. Looks like, yep, everything but things that are connected to a delta x should cancel out. Okay, so we got those canceled out. Now let's write our new clean line. Okay, we should have, I'm just going to throw that out front. And what I did is, because if you notice, there is a delta x in every term remaining, I pulled it out front and wrote the remainder. All right, we still got one delta x in there because it was squared. And that's all over good friend delta x. And as you can see, these are canceling. And so when we take the limit as x goes to 0, right, we're just plugging in our 0 for our delta x. We should be left with 6x minus 2. Okay? All I did was plug that 0 in for our delta x. Okay? Hopefully we're starting to understand this process a little bit more. Like I said, same steps. Those steps are laid out for you at the beginning of these notes. So if you ever forget, pull up these notes, look at those first 2 steps. They explain how to do it. Okay? So 3, here we go. Something a little different again. Let's start by writing our f prime of x. F prime of x equals the limit of delta x going to 0 of 1 over x plus delta x plus 3 minus 1 over x plus 3 all over delta x. Okay, so I had to write that whole thing out. The nice thing is, if you simplify this, you flip it, you expand it, you're going to get something that looks like this. It's going to equal the limit of delta x going to 0 of x plus 3, let's make it clean 3, minus x plus delta x plus 3 all over delta x plus delta x plus 3, x plus 3. Okay, you guys should be able to simplify that stuff with the fractions and the numerator and all that now. It's just expanding it on out, just like we've been doing. So from here, we're going to expand it one more time. Change colors up. We're going to make this into an x plus 3 minus x plus delta x plus 3. Oh, nope. Write the same line over again. Fool. It's going to be x plus 3 minus x minus delta x minus 3 all over delta x plus delta x plus 3 x plus 3. Okay, and when you start canceling out all this good stuff, right, we got all these things canceling up top, positive x, our 3's, This gives you a -1 out front. Don't forget, that's a -1 out front there. So you get left with a -1 on top when you cancel those out. Okay, so then and you're canceling them out. You're plugging 0 in for there to take the limit. You're going to be left with a -1 x plus 3 squared. I forgot my ending parenthesis right there. Okay, so a lot of canceling. Set yourself up. Make sure your work's clean so you can look through it, organize it, cancel it out right. The big thing is, don't forget that there's a -1 right there. So when you cancel out those delta x's, you're left with that -1 up top. That's the big thing. But overall, this is your whole answer. There we go. All right, on to number 4. Last one like this, and then we got a big one to finish. Okay, we got square root of x plus 2. So let's set it up the same way we always do. F prime of x is going to equal the limit delta x to 0 of square root plus delta x plus 2 minus the square root of x plus 2 all over delta x. Okay, again, you can simplify this. This is one of those ones where you get x plus delta x plus 2 and you're just, what we're doing, yep, there it is, minus plus 2 all over plus delta x plus 2 plus x plus 2. All right, and what we're doing is we're multiplying. What we're doing is we're multiplying that top and bottom to simplify it. Okay, kind of like its conjugate. We're multiplying by the conjugate. So we're getting delta x as it heads to 0. Should be left with something that looks a little bit like this. X plus delta x plus 2 minus x plus 2 all over delta x square root of x plus delta x plus 2 plus x plus 2. Okay, and from here, again, let's start canceling. This becomes a -x and a -2 because of that. So then you can cancel. Then look at that, cancel. So you should be left with the limit of delta x going to 0 of 1 over x plus delta x plus 2 x plus 2 2. And now we're just plugging in 0 for our delta x's, right? We're going to get a 0 there, which should tell us that we get 1 over 2 times x plus 2. All right. Easy enough. Now, we are headed on down to big boy problem 5. All right, there's a decent amount of work with this one, so I'll try to keep it clean. If I got to go to another page, I will, but let's just try to make this work for now. So, what we're doing. It says find the derivative of f of x at the given point. Okay, f of x, given point. Then find the equation of the line tangent to the curve at the given point and graph the function and the tangent line. Okay, so first things first, we're finding the derivative like we've been doing. So what's that mean? That means we're taking our f prime of x. We're setting it equal to the limit of delta x going to 0. Okay, and we're going to plug in our f of x. So it's going to look like this. X plus delta x squared minus 2 minus x squared minus 2 all over delta x. Okay, next line, we're going to have our limit as delta x goes to 0. And we're going to expand this sucker out. Here we go. We got x squared plus 2x delta x plus delta x squared minus 2 minus x squared plus 2. Okay, all over, you guessed it, delta x. All right, we can start canceling some of our stuff out. I see those 2's. I see those x squareds leaving us. I believe that's it. So our last line, our next line, limit of delta x goes to 0 of delta x. Let's see, delta x, we know it's going to be like that. 2x plus delta x. All right. From here, cancel them out. Now we can start plugging in our stuff. We plug in 0. We're left with 2x. Okay, so we found the derivative of f of x for the given, and now we got at the given point. So now the second part of this is we found the derivative. Now all we got to do is plug that point into our derivative. Right, we got 2x, so what's our x component? Our x component is that negative 2. So now we're going to take our f prime of negative 2. Okay, that should equal 2 times negative 2, which equals negative 4. All right, and what this tells us is that is the slope of the tangent line to the curve at negative 2, 2. Okay, this is the slope of the tan line at okay. So we just found the slope of the line at that point. We took the derivative of the function, we plugged the point into that function, it gave us the slope. All right, now the third part of this question is to find the equation of the tangent line to the curve. So we have the slope, and we have a point, so now all we have to do is plug it into our slope point form and get a nice y equals mx plus b in the outcome, okay? So I just like to use, this is my go-to, your y minus y 1 equals mx minus x1. You know, that little guy, right? Our m equals negative 4. Our point is negative 2, 2. So we're just plugging that in. So you got your y minus 2 equals negative 4 x plus 2, because x minus. All right, you should get y minus 2 equals negative 4x minus 8. And that should equal y equals negative 4x minus 6. So there's your line. there's your tangent line. Okay? Now, the last part they ask of us is to graph it all. Okay, so if we're graphing this function, let's just graph the original function to start. Okay, our x squared minus 2. So we know that means our vertex is going to come down here. We're going to have points at 1, 1. -3. It's going to look something like, yeah. Alright, so we got our graph right there. Now we wanted to find the tangent line at this point right here, -2, 2. And we found out the slope of it was -4, so that's going to be well, actually this is where that line's going to be, so that means this is going to be more like this coming inside. And that tangent line is just barely kissing. It's only touching at that one point. Okay, that's the big thing to take away from that. It's going through these 3 points. And that's what it should look like. All right. So, hopefully my drawing didn't ruin this lesson too bad. But let me know if you have any questions. Like I said, this is the fun part. We're finally getting